Okay, so we come to the last subtopic for this chapter and also the last subtopic for your SEM 2 physics. So I guess you will be very happy because you have already learned all. Okay, so here for your AC through your RCL circuit. So it means that there is an inductor with inductance L and also a capacitor with a capacitance C, and also your R resistor with resistance R is connected in series through a source voltage V. So here V is denoted as your source voltage, while your VL will be your voltage across inductor, and your VR will be your voltage across resistor, while VC is your voltage across capacitor. So remember, for a series circuit, so the current that passes through or in the circuit is actually the same, which means your I is the same for all throughout the circuit. So it means that your IL, IC, and IR are actually equal to your current circuits. Okay, so what you need to be more attention on this one is you have to be very clear which phasor is in phase with this which phasor. So you have learned that in your previous lesson. So we know that VR and your current are in phase. Okay, while your VL means your voltage across your inductor is leading your I by 90 degree or pi over 2 radian. Okay, for your VC is actually lagging your I by 90 degree or pi over 2 radian. So with these three information, so we know that we can sketch a phasor diagram according to this one. So you have your VR here, and I are in phase. VR and VI and I are in phase, while your phasor of your VL is leading I, means that your VL will be in this direction, which is your cosine wavefront, and this one will be your VC phasor. Okay, clear? So this is your phasor diagram. If you look carefully, so how do you calculate or how do you determine the source voltage? So you have know that a source voltage, so this one is your source voltage, is actually the vector sum of your y component x, your x component. Means that when you want to calculate the magnitude of your source voltage, it's actually your square root of your square of your x component plus your y component, square it and square root it using your Pythagoras theorem, because it's actually a vector form due to this one. Okay, so in other words, if you want to calculate your source voltage, so you have to know that what is your Vx. So if you look carefully, Vx is actually equal to VR because there's only one phasor at here. So Vx is equal to VR, while your Vy, because there is two components, your VL is in positive component and your VC is in negative component. So in other words, for your vertical components, your Vy will be equal to VL minus VC. Okay, remember, VL minus VC doesn't mean that your VL is larger than your VC. No, it's just a vector form. I wrote it in vector form. So if you substitute this one into here, so you will get VR square plus VL minus VC square square root it. So you will get your source voltage. Okay? So you know that all your I that passes through the inductor, capacitor, and resistor are the same. So we can factor out your I. So because your VR is equal to IR and your VL is equal to IXL, which your XL is actually your reactance through your inductor, while your VC is equal to IXC, which is your XC is your reactance through your capacitor. So if you put it inside this equation, so it will become like this, plus I square, so XL minus XC. Is it okay? Square root, so factor out your I square and square root your I square, so you will get I square root of R square plus XL minus XC square. So in other words, if you're comparing to your Ohm's law for your RCL circuit, so it is written as V equal to IZ. Why? This is jack. Okay, your jack is actually your impedance. Still remember what is your impedance? So impedance is actually your vector sums of your resistance and your reactance, because now you have two reactants and one resistor, so your impedance is actually your vector sum of your reactance and also resistance. So if you compare these two equations, you will note that Z are actually equal to R squared plus XL minus XC square. So if you want it to be more clear, so it's actually like this. So this is your Y component for your reactance, so which is your XL minus XC, and this one will be your R. So your impedance will be in this direction. Okay, so this is what you have to be very careful. And also this one. Of course, if you rearrange your equations, your I will become V over your impedance. Okay, now remember here your V and I can be denoted as, so here your V and I can be as V naught or r.m.s of the source voltage, which is your source. Okay, while your I is actually I naught or r.m.s, it can be denoted as I naught or r.m.s, doesn't matter. If you are using V and I, it must be pairing. Means if you are using V naught, then your I have to be I naught. If you are using IRMS, sorry, this is VRMS. Okay. So if you are using VRMS for this equation, so automatically your I will be IRMS. So your V here is a source voltage or source RMS, not each one. Okay, so next you have your impedance and also your voltage sum, your source voltage. So here you have to be very clear that because your source voltage and I are not in phase. Why are not in phase? Because there is a phase difference. So how do you find either is V lagging or leading I in this circuit? How do you know that which one is leading, which one is lagging? So it means you have to find out by angle, this angle, what is the angle that in between your two phases, which is between your source voltage and also your I. Okay, so in order to calculate your theta, so we have this one. So if you put this one into here, so you will note that for your vertical component of your voltage is actually VL minus VC. VC at here is due to its in negative component. So we just put it in one component, which is your vertical component, and here is your VR. So in other words, V is in this direction. So in order to calculate this angle, so we know that tangent theta is actually VL minus VC per VR. So this is the way to calculate your theta. So because three components have the same current that passes through, so we can denote this equation into this. So I don't want to show you again because you have already learned in your previous lesson. So if you don't understand, please refer back to your previous lesson. So if you look at this one, so tangent theta is actually XL minus XC per R, or VL minus VC per VR. So there's two cases. So this one, what happens to your value of for the first cases? Okay, so because your phasor V and I can be either lagging or leading. So how do you determine which one is leading and which one is lagging? So there's the first cases. So when your VL greater than VC or your XL is greater than XC. Okay, means that when you have XL greater than XC or your VL is greater than XC, so you will get your phasor diagram in this direction because VL is in positive component. So you will get this type of diagram. Well, this one is your source voltage and this one is your voltage across resistor. So if you look at this diagram, so you know that the source voltage are leading your I because your I is in phase with your VR, so your source voltage is leading I by angle theta. So how do you calculate theta? By using this equation. So there is a second case at here. So if you look carefully, okay, you will say that if, let's say, VC is greater than VL, okay, let's say your VC is greater than VL, or we call it as SC is greater than XL. So what happened? So if you have VC greater than VL, now your diagram at here, because VC is greater than VL, so your vector diagram has a negative component at here. Because your VC is greater, so you have your component, Y component in this direction because VC is greater, so your the resultant voltage at Y component will be towards the negative direction. So in other words, your source voltage are here. This one is your source voltage, this one is your VR, and this is your phasor I direction. So the angle that you are getting here are actually angle at here. Okay, so in this case, if you look carefully, how do you analyze this phasor diagram? So we know that it is actually moving in anti-clockwise direction. So in other words, we say that the phasor I is leading V by angle theta. So there are two ways to determine which one is leading which one. So it's very you have to be very careful. So look at it, which one is a bigger value. So if you have L as bigger value, means your V is leading I. If you have your capacitor has a bigger value, then your I will be leading V by angle theta. So I think I have finished all the key points and the highlight of this RCL series. So what you have to be remember here is your source voltage, how you calculate your impedance, and also the cases of your RCL series circuit. So there are two cases here. So which one? Which you have VL greater than VC, then your V will be leading I. And if you have VC greater than VL, then you will have I leading V. So that's it for this subtopic. So I want you to finish up your exercise 18.8 in your textbook. Oh, sorry. So I want you to finish this exercise and also your objective question for your textbook. Not to forget your essay questions for page 329. Okay, your essay questions at page 329, questions 1, and also your past year question in your past year exercise. So that's it for your MCO lessons. If you have any questions that you want me to discuss with you, which you need any guidance through video, just message me or private message me, so I will show you the example or the solutions using video if you want it. So don't feel shy to message me, okay? So remember to complete your work. If you doesn't complete your exercise, you don't know what you understand or not understand. So